Sometimes it's useful to calculate or use the mass percent composition of a compound. And what that means is the element's percentage of the total mass of the compound. So here's an equation that helps us to see what that is. The mass percent of element X, just whatever element you're interested in, is the mass of X in a sample of the compound divided by the mass of the sample times 100. And this follows the general pattern of what a percentage is. So in general, percent equals the part over the whole times 100. And if you remember that, you can figure a lot of these things out even if you forget what exactly the formula was. It's the part, the mass of the element you're interested in, divided by the mass of the whole thing, times 100. Now this percent should never be greater than 100%, right? So let's look at something like this. 2.45 gram sample of strontium reacts with oxygen to form 2.89 grams of strontium oxide. Use this data to calculate the mass percent composition of strontium in strontium oxide. So the numbers in these problems are always important. 2.45 grams of strontium and 2.89 grams of strontium oxide. And they're asking us for mass percent of strontium. So we want the percent strontium. That will equal the grams of strontium divided by the grams of strontium oxide. The part over the whole. The mass of just the element divided by the mass of the whole compound. And then times 100 to make it a percentage. Well, these numbers were given to us. 2.45 grams of strontium. And the mass of the compound is right here, 2.89 times 100. 2.45 divided by 2.89 times 100. Each of these numbers has 3 significant figures, and so our percentage should also have 3. It'll be 84.8% strontium. Any questions? Part over the whole times 100. Mass percent composition can make a really useful conversion factor. Another way to think about percent, like here, the mass percent composition of sodium in sodium chloride is 39%. That means 39 parts per 100 parts. Percent, cent is 100. Per 100, parts per 100, 39 grams of sodium per 100 grams of sodium chloride. When they give you a percentage in a problem, always write it down that way, and it makes a great conversion factor. So this relates grams of sodium to 100 grams of sodium chloride. So back to that question at the beginning of this lecture. 2.4 grams of sodium per day. How many grams of sodium chloride can you consume? And here's this piece of information we need. 39% sodium by mass in sodium chloride. So what does that mean? 39 grams of sodium per what? 39%. So if I had 100 people and 39% of them liked M&Ms, how many people out of 100 would like M&Ms? 39, right? So 39% means 39 out of 100. But this is by mass. Wow, that was loud. 39 grams of sodium is equal to 100 grams of sodium chloride. Why? Because they told us 39%. 75% of my oldest son's kindergarten class were boys. Doesn't that sound like fun? 75%. If there had been 100 children, which thankfully there were not, how many would be boys? 75. 75 out of 100. That's what percent means. So here we have this relationship that comes from this percentage we're given. 39 grams of sodium is equal to 100 grams of sodium chloride. So if we have 2.4 grams of sodium, I'm lost here in my zooming around, this many grams of sodium, and we want to know how many grams of sodium chloride. This is the relationship that's going to tell us. We'll just do a little one-step conversion. 2.4 grams of sodium times, we want to multiply by grams of sodium chloride, and we want to divide by grams of sodium. If you don't put the units in, it's really easy to get the numbers backwards, and then you get the answer wrong, and that's never good. And it doesn't take long to write the units in. You really, really need to write the units with your numbers. So here's grams of sodium chloride on top, grams of sodium on the bottom. Here, 39 is the number that I have with sodium, and so I put that with sodium over here. And 100 is with sodium chloride. And so I need to keep them together. Because all of these conversion factors, what is on the top has to equal what's on the bottom. That's the whole idea of dimensional analysis. And so these units cancel out. And I get 2.4 times 100 divided by 39 equals. And my initial number had 2 sig figs, and my percent has 2, so I'm going to give 2 sig figs here. It's going to round it to 6.2 grams of sodium chloride. So you could eat 6.2 grams of sodium chloride, which is quite a lot, actually, and be under that limit of sodium per day. Of course, that means you can't eat any food because your food all has sodium in it, too. Any questions? Yes?
Is the whole compound always going to equal 100 grams?
Yes. Because of it being percent. Percent is literally per 100. So we're using grams because that's a convenient unit of mass. It's this many grams per 100 grams. There are other ways to solve problems with percents. And if you're good with percentages and you want to do it another way, that's fine. But write it out clearly so that we can see what happened. Any other questions?